PhD, PhD, PhD है। हाँ, आज अपना डॉक्टर की रहा है, நான் பேருக்கு எனக்கு இன்ட்ரெஸ்ட்
Hello everyone. Welcome to all of you into the fifth live interactive session for the course Artificial Intelligence and Machine Learning in Materials Engineering, which is being instructed by Professor Krishanu Vishwas, and I'm Shivam Aggarwal, PMRFTA for this course. Uh, I will going to give you some hand-on experience about the how the machine learning can be used in the material science the and the engineering. So in the last session, we have taken some example. We have taken some example in which they have predict the staking fault energy by using the machine learning. So here we are going to take another example where we will give the some classific. We will see a classification problem. How we can solve that. So this is the outlier. There are the some question in the last session. There is a one question is about the outliers. What is the outliers? Outlier is the observation that lies an abnormal distance from the other values in a random sample from a population. There is a data, but there is some points which are far away from that data. Here I here you can see some example this is the plot. Here you can see every point is lie on this line, but this is the point which is far away from this data. So we can say these are the outliers. If I see this age data for any class or any office, so you can see the all the data is lie between around 20 to 50, but there is a point which is lie about the 90, which is far away from this population data population. So we can say these are the outliers for this. Same as here, this point, that point is kind of a outliers. In this scatter point, I can see all the points are near to this straight line, but this point is very far away from this data. So we can say these the outliers. And here you can see the all the data point is lie between around the 20 to 30. But is this point is a very far away from this original the population of the data. So this kind of point is generally called the outliers. So when we working in the like any statistical part or any machine learning model, these points can be a problem for our model to determine the output. So that's why there is a need to remove those points because it gives the false information about the data. Just suppose you are going to take a mean of this data. If you see that mean of this data is around this point, but if you take the mean about mean this data, so that will be shifted towards the left, the higher value of the age. So this kind of point may be a problem for the our machine learning model. So there is a need to remove those before any model training. So there are the different kind of methods which can be used to remove outliers. Some are the you can also remove these outliers by manually. Just suppose you know the all the data is lie between the 20 to 30. So you can fix the minimum and maximum, and you say like the minimum value should be the 20, and if any point is lie below this value, so that will be removed. Same for the you can fix the maximum. So there is a method which generally we use in the Python to remove the outliers, which is called the IQR, interquartile range. How this is used? Here we choose the minimum and maxima for the data by using this formula, Q1 minus 1.5 into IQR. This will be the minimum value. This should be the minimum value of the data, and maximum value should be the Q3 plus 1.5 into IQR. Q1 is the first quartile of the data. It means the 25th percentile of the data, and the Q3 is the third quartile or 75th percentile. percentile of the data, and the difference between this Q3 minus Q1 is called the IQR range. Yeah, interquartile range. So you can fix your minima and maxima of the data by using this formula, and all the data which lie after this, like the maximum value or below the minimum value, that those values are removed from the data. So this is the method which is generally used to remove the outliers from the data set. So you can use this, or you can also choose some manual values from which the data should be removed, or which data you want to take for the further model application. And there is some question about the k-fold cross validation in the last lectures, where we used this method for the validation. So this the k-fold cross validation is a just a resampling technique. What is a resampling technique? In the last interactive session, I just discussed like the people split the data into the two part, train and test. Train data is used for the training the model, and test is used to evaluate the model. So there will be some biasing with the there would be some biasing with the train and test, like for the this training, this test set will give the higher values, or this test value give the lower values. So we don't know what will be the like the model, how it will be performed when it will be going to the test for the whole data. So for that purpose, we use a resampling technique, like we choose the different uh, test and different training set. So for that purpose, we in this k-fold cross validation, we distribute our data into the k parts. Like here you can see there is a 5 parts. So I just take k is equal to 5. Then my data is split it into the 5 part, 1, 2, 3, 4, 5. And the first one is used for the test, and these 4 parts will be used for the training. Uh, it means this k minus 1. And for this, the model is evaluated. Now that test data will be replaced by using by this uh, by this part, and now this part and this one are used for the training. Same as every part will be used for the test, and every part will be used for the training. And then the average mean of the evaluation matrices of this 5 times model training and testing will be used to evaluate the model. And this kind of validation gives us the generalized values for the accuracy of our model. Like what will the R2 score, what will be the F1 score, kind of. So these are the some question will which was raised in the last session, and now we are going to the new example, which is this is the common workflow for the any ML model, how it will work. First, we have to go for the data, then we have to go for the feature engineering, then we have to select the model, then the model should be evaluated, then we will go for the prediction part or the analysis part of our model. Now, this is the example now for which we will work today, and we will try to do the machine learning for this work. And this work is published by the Rahul Mitra et al. In the computational material science. This is the title of this work is the Adasine assisted machine learning for phase prediction of the high entropy carbides. So in this work, the what's the high entropy ceramics? High entropy ceramics are the multi-component material, multi-component, like there are the various elements are used for in the equivalent space. Just like in the last lecture, we also discussed about the high entropy. And in this ceramic range, the carbides are very in in the high entropy materials, the carbides are also getting the have the high interest due to their properties like high melting point and exceptional mechanical characteristics at the high temperature, and due to having the large compositional range, and there is a need to be like uh, which material I am thinking about that would be like formed or not. So in when we talk about in the binary alloys, there is some empirical technique which can be used to check these material can be formed or not. But when multi-component are used for any material, that is a very become a very big problem to screen those composition will be formed or not. For that purpose, in this work, Mitra and all use the machine learning to predict the formation of the material for the high entropy carbides material. Like in this work, they use the machine learning, and there is some limitation in this work, like the for the data set. Like there is a very narrow data which can be used because there are the some binary material which are generally formed in the carbide, and we have all the data for those composition. But when we talk about the high entropy materials, there is a very few data point. So there it will be take more time if we go for the experimental technique to get the data. For that purpose, here they use some synthetic data technique. Like by using the some synthetic data, they uh, they uh, uh, they made some synthetic data, and they use those data in the machine learning to predict the formation of the materials for the high entropy carbide. So there here they use the some technique which is called SMOTE, synthetic minority oversampling technique. But there is some problem with the this SMOTE technique because it creates the synthetic data, but there is a problem in this synthetic data formation. That data is formed in like it's not formed in the weighted way. Like there is a some minority data and there is a some majority data. So in the minority data, it will not going to give the some weightage for the composition. Like it will distribute, make the data in certain way that will fill all the area. Like it just make data with the some errorness and some unreliable outcome. But by using the adapting technique, which is the adaptive synthetic sampling, in this technique, it will create the data in such a way the minority sample will be distributed according to the or density distribution of the original data. So it will not going to change the any density of the original data, but it will also create some new data also. So that's why those people use this technique to create the data. First, they use the smarter technique, and then they use the addition technique to get the some reliable and some more accurate data compared to the smarter technique. Now, initially they use the some 45 elements from the periodic table to check their elemental carbides, and position those carbides according in this plot, like with the difference between the pseudo potential and with the difference between the Pauling electronegativity. And they check where the monocarbides are formed or not. And they found some range where the monocarbides are formed, and they see there is some range where monocarbides are generally not formed. So for the quaternary carbides, they found like uh, difference between the Pauling electronegativity. Any question?
Mm,
So they use some sorting parameters which can be used for checking the formation and not formation of these carbides in the quaternary and the carbide. This is the some sorting criteria which they found by analyzing their data and some literature. Now, and these are the some features they used for this model, like ratio of the ratio of the anion and cation and the difference between the Pauling electronegativities and difference in the molecular electronegativity and they also use the enthalpy of mixing and entropy of mixing and they also use the atomic size mismatch and these are the formulas for these features. RA over RC, RA over RC, it means the radius of anion over radius of cation, and this is the difference between the Pauling electronegativity. This is the difference of the Millikan electronegativity, and this is for the lattice mismatch, atomic size mismatch, and this is the mixing of enthalpy, and this is the mixing of entropy. Uh, After this, how your data look like? So first of all, we have to see. Okay, maybe I have stopped the sharing. Okay, maybe all of you are able to see the screen. So all of you are able to see this Excel sheet.
Yes, it is visible.
Okay,
Yeah.
so this is the difference between the Mulligan electronegativity for the composition, and this is for the ratio of the ionic radius of anion and the cation. This is the difference of the Pauling electronegativity, and this is the uh, uh, size mismatch, and this is the mixing enthalpy. This is the mixing entropy, and this is the phase formation. Like there is the that composition is the multi-phase or the single phase. So our in this work, first we have to change these multi-phase and single phase with the some numerical value, and we changed multi-phase with the 0 and single phase with the 1, and that will be used for the further work in the machine learning. So this our data, this is the input and this is our output. So now first of all now it is requested to all of you, please open the Google Colab. Search the Google Colab in the Google search and then click on the first link. Then click on the new notebook. Okay. Now I shared a link in the chat box. Please open. Please open that link. Is there any problem in opening the this Google Notebook or this code share link? Maybe all of you are able to do that. So now we are going to start. So first of all, we have to load some libraries like pandas, numpy, etc. I have pasted that code in that code share link. So please copy that code from here and paste this code into the your Google Notebook and press Shift plus Enter to run that cell. And you will get some green tick here. So that it means your code is run. Anyone got any problem in this? Now, this is the Google Drive link of this data, which I have earlier uploaded in this folder, which is the dataset 2, Rahul Mitra et al. And this is the link for that data. So, for loading the data from the Google Sheet, uh, I have to use this code. First of all, I have to define my sheet URL by using this code, and this is the link for my data set, and then data is equal to pd. Pd means pandas library dot read underscore csv. This is used for the csv file, and this is the sheet url which is defined here. So if I press run this code, it will going to read that data in this sheet. So is there any problem? Okay. Now I have loaded the data into the Python. Now I have to see how my data look like. So for that purpose, there is a code data.head. So this code is used to see some rows of my data. Generally, if I have not write any number in between the this bracket, so it will show the upper five rows, top five rows. If I give any number like 10, it will going to show the top 10 rows here. So these the sum my data look like. So there is a some column delta x Millikan R over RC, delta x falling, delta x mixing, delta s mixing, and phase formation and the formation. So As if you want to see are the column in this data, so for that purpose, there is a code data dot columns. Data dot. So there is a if you can also use this only don't use the print command. So it will also going to the same answer. Is there any problem until now?
No.
Okay. Now there is a data in which you can find these are the column, and in this column you can find this is the input and this is our output. But there is a no importance of this column now. So for that purpose, I will divide my data into the two parts. What will be the input and what will be the output. For that purpose, I define my x is equal to data and the name of the column which are going to be x, and our target column which is going to be our y. It means output property or target property. So if I run this command, it will make two data x and y, and x have the columns, those columns which are going to be used as a input properties, and the y will going to be used as a output property. If I want to see my x data, so for that purpose I have to write the same command like as I see the data, original data. So x dot head, so it is going to show some top 5 rows, and here you can see there is a no extra column. So this is for the some validation part, like you can see how your input properties are look like. Same as you can also see what is the y. Now there is something which we have earlier discussed in the last class, that is called the heat map, which is going to show the some correlation factor of that data. For that purpose, the heat map work on this formula, which is called the Pearson correlation coefficient. And this correlation coefficient is calculated by using this formula, summation of I to the I is equal to 1 to n xi minus x bar. X bar is the average of the value, and xi is the particular value, and y is the corresponding value of the y correspond to the xi, and y bar is the average value of y, and same as here, and this formula is called the Pearson correlation coefficient, or sometimes it is called the R value. And by using this formula, Pearson heat map is generated. Now, what the information this heat map give? This heat map give the correlation between the two properties. Like here you can see there is some number. So here you can see the delta x Millikan with the delta x mixing. So there is a no correlation, like there is a correlation 0.01, which is like which is very close to the zero. If this value is very close to the zero, it means there is a no correlation, and if it very close to the 1 or -1, that will lead to the very high correlation between these properties. And positive number is referred to the positive correlation. It means it is if this value is increasing, then the other one also is going to increase. And if there is a correlation is minus near to the minus one, it means there is a negative correlation between those. So here you can see this heat map, and this is the correlation value, or yeah, or you can see the PCC value or R value. And this kind of plot is called the heat map. Now, we have also discussed if you are going to use any data for the machine learning, then you have to split that data into the two parts, like training and test. What is the training data? Training data is used will be used for the training your model, and what will be, do the test set? Test set will be used for your the validation of your model, like to test your model. Is it working or not? So for that purpose, we are going to split our data into the two part, train and test. And in this work, data is split into the two part with the 3:1. That's why I have used this ratio here. And you can see there is a test size is equal to 0.25. It means test size will be the 0.25 of the whole data. And the other data will be used as the training. And the random state is used 25 here. So I have also used here 25. You can also choose any number, any other number also, like 42, 11, or any random number. And as so now I have also discussed in the uh, last class. So there is a every time we see the range of our input property. That range is is not the same for all the input properties. Like here you can see there is a range around if I want to show you the range. Here you can see the minimum value of this output property, this input properties, and this is the maximum of these input properties. So there is a various range like 1.9 to 2.8, 0.3 to 0.5, 0.4 to 1.1, and it is a 0.0152 to 0.15, and this is a minus 42 to 16, and is the very large range. And you can see there is a various orders in this input properties. So by having the this different range and different order of the input properties, there is a some thing which can be make a problem to our model in the training part. So for that purpose, uh, we use some technique, normalization and standardization technique, which make our data to take any standard. Like in the last session, we have used the min-max scalar. In the min-max scalar, the our data is confined between the 0 to 1, and it will get normalized according to that. So here we are going to use the standard scalar. What that parties do, that is used to do like it will make the mean of the data is going to be 0, and the variation of the data is going to be 1. Like it change our data in such a way, it will make the mean of the data is going to be 0, and it will going to change the variance is equal to 1. It means 0 mean and the unit variance. And how it do that? By using this formula, z is equal to x minus mu over sigma, where mu is the mean of the data and the sigma is the variance of standard deviation of the data. So this is used to standardize our data, and that is implemented here by using this library, uh, this code. So first of all, I have defined the scalar. What is the scalar? Scalar is equal to standard scalar, and then I fit that using to the x train. So I make the unit variance of the x train data and make the unit variance of the x train. Then I transform according to that train for our x test. So this is the code for the standardize our data. So these are the features they have used, and this is the technique they used for the heat map and the standardization of the data. And and this is the heat map they got before the Edison used, and after that they used the Edison. So the data which I have used, that is the post Edison data. Like they have done the Edison part on the data, and then we are going to use that data for the model. So first of all, we have to do the splitting of the data into the 3:1. Then we are going to use that train data into the training of the model and test for the evaluation of the trained model. Then we are going to use here four classification model, which are like KNN, random forest, support vector machine, and uh, gradient Navier bias. And after that, we are going to use the five-fold cross validation to check the generalized performance of our models. And then we will going to use some grid search CV for tuning the hyperparameters of our model. So we have discussed about the k-fold cross validation earlier, and what will be the hyperparameters. Hyperparameters are the parameters of the of any ML model. Like ML model is working on the some parameter basis, so we can tune those parameters of any ML model to get the perfect model for our data. So So first of all, we are going to load any model. Like I have defined the KNN model is equal to K neighbor classifier, and N neighbor is equal to 5. This is the just I has said like there is a need to some give the some parameters to our ML model. So any KNN model require the number of neighbors. So for that purpose, I have used here N neighbor is equal to 5, and then I fit this model by using the KNN model dot fit. I have to fit this model onto the X train and Y train. Then that will going to be predict for the X train, and that will be going to the predict the X test by using the command dot predict. Like name of the model I have given earlier, KNN model dot predict. What have to be predict? X test. Here X train, and they are going to be saved as a X train pred and Y test pred. You can also choose any other word for this. Like you can also write like the pred train, anything you want as you want. but you have to take that word into the mind. So you can use that in the some upcoming parts. So now I have to calculate the accuracy of the data of the this trained model. So for that purpose, there is a accuracy score for this, and how this accuracy is calculated here. Like in the regression part, there is some random, there is some R2 score and RMST value, mean absolute error, something like that. So for the classification models, there is a some other evaluation matrices which are called the accuracy score and the F1 score. So what are the accuracy score? Like just suppose there is a our data. This is the actual class like positive and negative, like and this is the predicted class. And what is the our model going to be predict? And what is the our model is predicted like positive and negative. If our positive actual positive is going to be predicted positive, that is called the true positive. If our positive class, positive data is going to be predicted as a negative, then it is called the false negative. Why false negative? It is actually positive, but our model is going uh, give it to the negative. Same as if our data is a negative, actual data is negative, and our model is going to be giving it a positive, then it is called the false positive. If our data is going uh, our model is going to be give our data is a negative data to the negative, then it is called the true negative. So so this is also the error and this is also the error. Why? Because our positive data is given negative and our negative data here given is positive, and it is called the type 1 error, which is called the false positive, and this is called our type 2 error, which is false negative. So it means false negative is they are actually positive, but our model give them as a negative. And what is the false positive? Our data, actual data is negative, but our model give that as a positive. So this is called the type 1 error, or it is called the false positive. Now we can calculate the different parameters by using this confusion matrices. This called is the confusion matrix. And by using this confusion matrix, we can calculate the precision of our model, which is given by this formula TP over TP plus FP. TP it means true positive, true positive, false positive. And we can also calculate the negative predicted value and sensitivity and our specificity of the model, and the formula for the accuracy is given by this TP plus TN, true positive plus true negative over true positive plus true negative plus false positive plus false negative. And these are the some other formula for the F1 score, which is generally calculated, and it is given by the 2 times of the precision into recall over precision plus recall. Recall is over the sensitivity of the data. Sensitivity is sometimes called the recall also, which is given by the TP over TP plus Fn. Okay. Now, so in this work, they have used the for model like KNN, RF, and GNB and SVM. So this is the code for the KNN. So we are going to check the accuracy for the train test and the accuracy score. This is the command for to check the accuracy score for the model, and then we write the Y train and the Y train print because I want to check between these values. And then there is a command for the print that value, and then there is a test accuracy score, Y test and Y test print. So if I run this code, I'm getting that 0.97 for the train test, and for the test, I got the 0.9292. Please copy this code from here and use this code. Have you get the same values for the
Yes.
accuracy? Okay.
Yeah, I have it.
Now I have run the I have run this mod KNN model only. But in this work, they have used a four model, and you can also use any other model also. So here you can see in this work, they have used the KNN, random forest, support vector machine, and the Gaussian previous bias. I have used these all the models here in this single code, and first of all, I have defined the model name which are going to be used like KNN, RF, support vector machine, and the Gaussian Navier bias. And then I have to see the accuracy of this model. So for that purpose, I am going to make a list where the data are going to be stored for the accuracy for these models. And then for the evaluation of the model, first of all, they are going to be fit model.fit. So what this command will do, it will take the model from here. Then one model is going to be fit by using this data x train by train. Then the accuracy will be calculated by using the for the train data, and then it will going to do this for the test data also. And after that, I will got the I'm going to print these accuracy values. And after that, I'm also going to plot this accuracy in form of a plot, bar plot. So this is the code for the bar plot. This is the specification, and this is for the like what are going to be uh, plotted like train accuracy and the test accuracy. What will be the color for those, and the some other parameter which you can be tuned. This is the X label, this is the Y label, and this is the title of the plot, and this is the X ticks where the ticks will be, and what will be the legend, and what there should be grid or not, and this PLT dot show for the showing the date, showing the plot. What is the PLT? You can ask me if you see the early part here. I import the matplotlib.pylot as a PLT. So if I write the PLT dot, it means matplotlib.pylot is going to be used. So it means here here I'm using the matplot library. Please copy this code and paste in your Google Notebook and run this from here. So you can check this code by using the different values like if I'm going to change grid. So now the grid is is removed, and maybe you got the same results here from here. Have you got the result? Is there anyone who run the code?
Yes.
Okay. Are you got the output from this?
Yeah, yeah.
Okay. You got the same results or some other values?
I will check once.
Okay.
Same values we got.
Okay. Uh, uh, Here, if you see, I have also used the cross validation. What is the cross validation? Which I have earlier discussed. This is used for the generalization of our model. And you can see I have used this CV score is equal to the cross validation score for the model, for the all models, it means. And then it will going to be work on the X train, Y train, and CV is equal to 5. It means it will divide our data into the 5 part. Then it is going to be print the model name and the NP mean CV score. It means what CV score that will be get from here, then it will calculate the mean of those scores. And that is printed here. You can see 0.94, 64, 0.96, 0.93, and 0.8988. So here you can see which model are working according which model is going to perform well. So here you can see for the random forest model, you got the 0.96 as a cross validation score, and here you can see the trend accuracy is about 1, and the test accuracy is a 0.95. But if you can see about the KNN model, it is about the 0.97 for the training set and 0.92 for the uh, test set. And if you see the the cross validation score for the KNN, it is about the 0.94. So so here you can see this is working best here. But if you see about the difference between the test accuracy and the train accuracy, because this difference should be the minimum to get the generalized model. So if we see that, we can see the KNN is going to be work best, high plus more generalization. You can see, you can say me here we got the for the same accuracy for the train and test. So we have to choose this if I talk about the generalization. But there should be the high accuracy as well as there should be the low difference between the training and test accuracy. So that's why we are going to choose the KNN as a best model. But here you can see we have not still tune our model. Maybe there is a there will be the change in the accuracy between the in the models if I choose the grid search. For that purpose, we are going to check make a grid. So here you can see the model parameters for the KNN. I'm going to use parameters like n neighbors, weights. For the random forest, there will be the parameters, an estimator, maximum depth. For the support vector machine, there will be the C value, kernel, gamma, and there will be the Gaussian Naive bias. There is a parameter like various variance smoothing. So this parameter is going to be tuned, and here you can see there is a individual values for the model. You can also tune those, like there is a n neighbors is 3, 5, 7, 9. You can increase those like 11, 13. What you want to give? Like in the same as for the n estimator, there would be the some more values for those. So same as C value can be tuned. So this is for the like for the grid search as well as for the accuracy, like as we done earlier in the last code. But there is some addition which is for the cross for the grid search for the hyperparameter tuning. Please copy this code and paste in your notebook and run it. Have you also got the output from this code?
Yes.
Okay. Uh, Maybe you can see here now the accuracy is changed for the models. Like if you see about the KNN, it is increased, but when we talk about the random forest, it is decreased. It is about the same. And for the SVM, it is also increased, and for the GNB, it is almost same as the earlier. So here you can see there is the it gives the some parameter which are the best parameters according to the grid which I have given to this model. So here we have give this grid. So it is working on this grid. You can also add the some other parameters for the like there are the many parameters for every model which can be tuned. So you can choose those also to tuning the model. Here I just take the 2 or 3. So now here till now we have used our ML models. Then we have also checked those accuracy for those models, and then we have also see about the cross validation score for these models, and then we have also work on the hyperparameter tuning of these models. So after that, further as we see, we will select the KNN model as a best model for our work, and we will use these input this parameter as the hyperparameters for this model, and then so best parameter for the KNN, and I give these values, and now I'm going to train this model again by using these values, and then I'm going to fit this model. Then I will get the prediction for the test set, and then I will check what will be the confusion matrix, and I'm going to normalize this. What is the normalization means? Like it will take as a all value as a 1. Then it will normalize all the values according to that.
Yeah, is this same matrix which you have seen in presentation?
This is not the same actually, because
No.
here I have used the data, but I don't know about the like what will be the test and what will be the trained data for that work. Because as you run the code in the many times or any different times, you will get the different accuracies, the different test train splitting. So it is a very crucial to keep this in mind. You will not get the same values every time and person to person in the PC to PC also.
Okay, okay.
You will get the approx values, but not the same. So these are some accuracy parameters which they have got in their work. This is the untuned model, and this is the tune model, and you can see for the random forest we have also got the kind of same value, not the actual same exact same. And for the KNN also we got the 0.97 for the training part, and I think 0.92 about for the test set. And this is the parameter which I got they got after the hyperparameter tuning, and they got the very similar results for the KNN. So that's why they use the KNN as a primary model. And in the same thing, they have also got the cross validation score, and these are the values for the hyperparameter tune model by using the cross validation score for every model for the test set. Okay, and there is the some output which they got. There is a no significant variance in the accuracy between the KNN, SVM, and the GNB in the untuned model. And they got the testing accuracy improves as the hyperparameter tuned. We also get the same. And the KNN classifier has the best testing accuracy about the 0.956 and the smallest variation about the 1.13% between the training and testing accuracy. So that's why they choose the KNN model. And after the hyperparameter optimization, so RF method are performing about the KNN model in the cross validation score. You can also see here, and you can also see in our work also. If you check about the calculate the variance and check about the accuracy score. So there is a very low variance in the KNN model compared to the RF model. So this is uh, the confusion matrix, and this is the model analysis. How if I change the training data and how it will affect our accuracy score. If I choose the 0.25%, sorry, 25% data as a testing. If I will use the many more data points as a test or low the if I reduce the data for the training, how it will going to perform. So this is the thing they have done, and they have check about which value of the training example the performance is not going to be changed. Oh. So this is the confusion matrix, and they got the multi-phase and it is true for sorry. This is called true positive. This is the true negative. The same kind of thing which I also got. In this part, they have given the 0, 1 label, but you can also change this 0 and 1. 0 is used for the multi-phase and 1 is used for the single phase. So 0 is multi-phase and 1 is the single phase. So maybe you get the same kind of confusion matrix. Now, in that work, they also use the sharp analysis. Actually, sharp analysis is generally used to explain the model, how our model is uh, going to predict these values. So for that purpose, they use this shape analysis, and according to the shape analysis, they got the difference between the Pauling electronegativity plays the very crucial role to determine the phase of the material, and following by the mixing of entropy, and then difference between the Mulliken electronegativity, and if we see the size mismatch is the playing the very low role in determining, but it is also the significant values, not a very low value. So we can remove this feature. So here is you can show this. You can see this plot. Here you can see the as the electronegativity value is increased, it will going to give a positive value to the our output value. Here you can see this is a sharp value. Sharp value is generally says about the how much is going to be give the correlation to the output property. If you see there is a positive value, it means it will going to increase that value. And if it is a negative, sharp value is negative, then it means that it will going to low the value. So if you see as the electronegativity is increased, low to high, it is going to increase the sharp value. And if you see for the all the features, they are the same, but besides the RA over RC. For RA over RC, if the RA over RC value is increased, then it is going to give the negative sharp value. It means as the sharp value of the RA, sorry, as the value of RA over RC is increased, it means it is going to decrease the sharp value, or it is going to give a negative to the our output property. So it is going to decrease, and all the parameter is going to increase the our output property. So here we can see how we can choose our input and output properties accordingly. Now they also use this model to predict some prediction, and they check this composition, and they also check their formation, and what is your model is predicted for those. And they got there is a out of 8 out of 10 composition give the right uh, prediction, but two prediction is give the wrong values, like from the 10th for this 10th value, and for this value. So they make the wrong prediction. Otherwise, all the composition give the right prediction by using our predicted order. So now the prediction part, if I go for the maybe we have worked for the confusion matrix. Okay. Now you can also plot the sharp values, sharp plots. So first of all, you have to install this sharp library, because by default this is not installed in the uh, Jupyter. Sorry, in the this Google Colab Notebook. So first of all, you have to install this sharp library. Then you have to give your explainer into the model. So first of all, I have given to the explainer to the model. Then this explainer going to calculate the sharp values, which is by using this formula, this command. If I want to plot the summary plot, then this is the code for that. And this is for the bar plot. First of all, please install this sharp library. Then fit the explainer by using this command. First of all, you have to give the explainer. Explainer is equal to sharp dot explainer your KNN model dot predict what is going to be your model going to be predict, and what have to be predicted x test. Then it is calculate the sharp values according to this explainer. Sharp underscore value is equal to explainer x test. So it will going to check the sharp values for this data, and then you have calculated these sharp values. Now this is going to be plotted as a summary plot, like each sharp value is going to give a 1 point in the summary plot here. Each point here is going to give as a one sharp value. But here you can see there is a given like a feature 0, feature 2, feature 3. So this feature is the name. So you can change the name of this feature by see your data, how it look like. Like 0 is a reference to the column 1. 1 is referred to the column 2. 2 is referred to the column 3. 4 is referred to the column 5, and 5 is for the column 6. Have you got the summary plot?
I got the error. I texted in the chat.
Shape is not defined. First of all, you have to install this shape library. Pip install shape. Have you installed this?
Yeah, I have done that.
After the installing, you got this error. 1 minute. It's the auto traceback most recent poll test. First of all, please check the output of those installed library. Like when you install this, is there any output like this successfully? Kind of.
Yes, yeah, I got that one.
You got the same,
Yeah,
but you are not able to run this. Why? If there is a problem, there will be the problem in this. Please copy this output and please paste in the chat box. But otherwise, there should be no problem if this is installed properly. Can you please run this installing library code and then again can you please run this summary plot code?
okay, I will do that.
Please
Yeah, I run that pip install shap, showing that requirement already satisfied, and the fits the explainer showing same error only.
the same error. Maybe
Yeah.
1 minute. Why this error is coming? Pattern into 21 fits the explainer is equal to show dot explainer by predicted extends to third explain name error. Name shape is not defined. You have already stored this. Uh, can you please run this please open this tab runtime and then click restart session and run all.
Okay.
Maybe that will solve your problem, I think. Because sometimes this happen with the shop or any library. So we have to restart our kernel. Have you got any output or not?
It's still running.
Still. Ishwar, I think there is an announcement yesterday about this session. I got the mail also.
Showing in, but it is not showing in mobile. If we open laptop in Swayam portal, it will be shown. But in a mobile app, it is not showing. Because of I'm not there in a place in where I should open the laptop. That's why I cannot see the laptop. That's why I'm asking. Whether I want to join in the whether I want to join in the session means I want to know about the live session, right? That's why. Now I
It's okay.
received that.
But please keep in this mind, every Saturday there is a session, I think. If until you got any email regarding the cancel the session or any rescheduling about the session. Every
Last
Saturday from 6 to 8.
this Saturday. Last
Huh.
session also I have seen in after opening the laptop only. In mobile it is not showing anything. And in Swayam portal it will there is lesson session, right? Lesson something live session it will be there. On that also showing the first live only it is showing. No nothing of after the first live it is not showing anything because I want to see the and
It's
I
okay.
have skipped live
Please
sessions
save.
because of this
Save.
Swayam.
Okay, it's okay. If please copy this link about copy the link of this session and you can open that on every Saturday from 6 to 8.
Okay.
Okay, there's a no problem.
I have missed two lessons, two sessions. That's why I'm worried about it. What I have missed, I don't know.
It's okay. It's okay. You have got the recorded session. You can see that session.
There is any YouTube videos recording this? Yeah, recording videos.
Yes, you got the recorded session on the YouTube.
Where can I check it? Is on the
Maybe
section
there
of.
is a Google Sheet. I think there is a
Okay, sir. Okay. Thank you, sir.
Bhaskar. Use this link. I'm pasted in the chat box. Okay, Nikhil, just left this point. So we will start. Maybe there is some problem in your PC or any kernel. You can try this in. Are you working on the Jupyter also or not?
No, no, no.
So you have not used the Jupyter. Sometimes this error occurred, but that is removed by the restarting the kernel. But I don't know why it's not removed in your case. Please check the spelling of the shape, I think, but that's the same.
Yeah,
I don't
it
know.
is same. But no.
I
I will
don't
check it later.
know. I
You can
just
continue.
maybe I think there would be some problem in the installing this. Otherwise, it's not going any. Okay, just left this and we will encounter this problem in the next session. I will go for this like why it is occurred in your PC.
Okay, sure.
Is there any? So I have pasted the code for the sharp code for the summary plot and the bar plot. So now for the prediction part, like there was a question in the last session also, how we can get the prediction from this predicted model, this the trained model. So for that purpose, first of all, as uh, I have to prepare a set which I want to be predicted, like for which I want the prediction. So for that purpose, just look like in this data. So this data is prepared by Rahul and Rahul et al. Rahul and others. They have used these for the quaternary carbides, and they use this composition in the equimolar ratio, and they have calculated the features of this composition by using this formula which are given in the paper, and I've also shows those formula in the PPT, and you can calculate it the difference between the electronegativities and the size mismatch and the mixing entropy, mixing enthalpy, and the ratio of the anion and cation, ratio of the radius of anion and cations. And why we are using you have calculated this because you want the prediction, and you trained your model according to these values, not these values. So you have to check these values. You have to use these values as a input. So roughly, I have prepared this data. I'm not Mitra and others prepare this data, and they use this data as a input and make the prediction for these input and get the output. So for that purpose, I already export this CSV file into the Google Drive. Here you can find this data, test data, and sorry. So I make the URL of that, and then new data is equal to pd.read CSV URL, and I save this data as a new data. So please copy this code and run. Bhaskar, are you getting the same error as the Nikhil code?
Yeah, I resolved it once. In this on this code we have not import.
Sorry, Nikhil, I have muted you. Please unmute.
Yeah, on that code we have not imported the shape. That's the reason we are getting error.
That's my. That I also thinking like your Google is not able to like rightly install the shape. That's why you are getting these problems, because it is showing like there is a nothing about like shape in your. It is given a name error. Shape is not defined.
Just type the import shape. That then it's got fine.
Okay, fine. Okay. So now your code is running.
Yeah, running.
Okay. So I'm also going to add import shape. Okay. Have you loaded these test data? Is there any problem in this code?
No, everything's fine.
Okay. So you got the data as these columns, and you can see the data in your output. So if I want if I want to see my 25 rows, so here you can see this composition and their properties, input properties. Now, if I have trained my model by using these properties, not these A1, A2, A3, A4. It means the composition names. So first of all, I have to remove this. So for that purpose, I remove uh, the first fourth column by using this code. You can also use the drop thing also. So after removing the first four column, I got my input data like this. So now there is a like final input. Now, if you see, firstly, I have changed our data into the standardization. Like I make the mean of the that data is 0 and make the standard deviation is equal to 1. So what thing I have used there, I use the scalar. Then I fit the scalar. Then I make the transformation of the X test. So my data is trained according to using this standardized data. So it will give to the output to the this standardized data. So if I want to the prediction, then my input data should be the standardized by using that scalar. For that purpose, I recall that scalar, then dot transform. So it will use that standard scalar, then it will transform according to that my data, my new data. So I run this. If I want to see my data, how it will look like. Sorry, yeah, it is not a PD data from, it's not a data frame now. So only new data standardized. So your data is look like minus 0.1 something. So now you have want to predict. So for the prediction, you have make a model, KNN model. So you have to see what is the name of your model, which you have uh, fit in the last KNN model. So this is the name. So I'm going to use this name KNN model dot predict what have to be predicted now. New data standardized. So I have write this and now this is the same like as I use the X train X test. So on the place of the X train or test, I have used my new data. It is a like which I want to be predicted by my trained model. So now new data I make this makes prediction. Now this prediction have to be saved in format data frame. So now this prediction are the saved into the new data by use predicted label. What label I want to give like formation. Now formation will be equal to the prediction, which prediction is given here. So I run this. Now my new data finally look like this. New data, new feature dot head. Now I add these column which are going to be give them give to the formation value 0 or 1 is added into the my original data which I have loaded here. So now you can see there is a column which are going to show the composition name. This is the feature value and this is the formation. So if I want to see some more row, so here you can see there is a one. It means this can be predicted. It should be single phase here, and the other are the zero. It means they are the multi-phase as it is predicted by our model. Now this code new data dot to CSV. This is used for the saving the data. Like if I want to save my data as a output, so how can I save that? So if as I run this, so if you want to see like where I my data is saved, so you can check your data is saved. Like this is the save key and prediction with input. This is your data. So you can, if you want to see this data, just double click and you can see here. If you want to download this, you can also download. This is the download button here. Bhaskar, can you paste the error? Which error you got as in the output? Okay, now it was. So it was corrected now. Okay. Uh, so don't run the code for the grid search. Maybe that will take time for you. If you want to run all the thing with us. Now this is the way so you can get the predictions. So from this work, they got the prediction same as I show you. And these are the some results which they got. They got the very high accuracy to predict a single phase formation or any multi-phase multi-phase formation, and they got get a very high accuracy in this, and they use the potential use of the addition in forecast in using the synthetic data to predict the formation of the single phase or multiple phase. And this the so I would like to thank you. So is there any question? If you want to ask anything, please. Have you got the prediction values from the last code? Are you able to hear me?
Yeah, but the code was got run, but we can't see any values there.
Which one?
Last code.
This saving the data.
Yeah.
Maybe you will not get any output, I think.
Yeah, I not got output.
Is there any green tick?
Yes, it is there.
So it was run.
Yeah, okay. I got
So you
confused
can
it.
check here. You can take on this file and there should be some
Okay.
CSV file.
Okay.
You got this? Please check.
Yeah, it is there.
So it was run.
Yeah, cool. Then I
So you
got
can
it.
double tick in this file and you can see that shit. Yeah.
Yeah, I got it.
Okay.
Thank
So
you.
you can tune this like how much entries you want to see here. And you can also download these Excel sheet. So that would be also be okay to check in your view.
Okay.
Okay. So maybe all of you, is there any question till now? I think. Bhaskar, have you got the same results or not got anything till now?
I'm running it. I'll take
Okay,
some time.
don't run the grid search code. That will take time. Otherwise,
Okay.
all of the code will be run in the 1 or 2 seconds.
Okay. Okay. Thank
If you are stuck in the grid search, then stop it, then run the next cell from the
Fine.
next cells.
Okay. Thank you.
Please confirm it if you got the results. Is there any other question if you want to ask about the code or about the how you can? Is there any specific problem you want to you want to learn about that how you can work on that problem? So I can prepare my next session according to that. I have uploaded all the notes in the folder, I think. Is there anything missed there?
Yeah, fifth week notes are missing. Fifth and sixth
Fifth week. This is the fifth session.
No, I'm not talking about this session. The sir which take.
1 minute. So there is all the session. Till now there is a 4th session. One. Okay.
Not
This
this
is the
one.
5th. So this will be uploaded now.
No. I'm not telling about these sessions. The sir will take lectures, right?
Okay. Sir, I'm not. So you have to. Okay, I will convey your message. But you can ask this query into the like question answer, which is
I have, in
there on the
feedback, I
SWIM
have,
portal.
no, in feedback, I have responses that one, but I couldn't got it.
Okay, maybe that are in the processing because this course is running the first time. This is a fresh course actually. That will take time.
Okay, okay.
Shivam, I'm not able to find like your previous lectures and slides and code. Like you said, key somewhere it will be uploaded in the drive, but I'm not able to find the drive itself.
No, no. See which drive you are working. Like here you can see. I can show you how you can get that. You can see there is a. Okay, sorry, that's my bad. Uh, you know in which Google Drive you are working?
Uh, I did not get you.
No, in your laptop you are working any Google account.
Yeah, correct. Like one of the accounts is
Okay,
linked with NPTEL, but I'm not able to see all the lectures of this. I mean, sorry, your recordings and then slides, code in that.
actually I have not shared the code in any like to you. I just shared code here in the class. So that's why
Okay.
you are not getting the. But maybe in the last week, someone asked me the code in the YouTube comment. So I have pasted here the link of the code. So you can check
Okay.
there.
Okay, but
And I think
actually
in the
your
third,
slides are not like I'm not able to get your previous 2, 3 presentation slides.
there is a uploaded maybe. Please check this if you are not getting. I will again share this link.
Yeah, I'm not having that link.
Okay,
Yeah,
I'm
please.
sharing in the comment box. You can get it.
Okay, okay.
Maybe
Thank
that
you.
is on the same portal, I think.
Please share it. I'm not sure. I'll just check it if I have it. Thank you.
Uh, okay. So any other question?
No.
Okay. Okay, so let's end this session. Thank you so much. Uh, if you have any query, please post that on in the question answer, or otherwise you can also make the query into the comment box of this lecture, this session. Actually. Okay, bye.
Thank you.
Thank you.